Ever wondered why your machine learning models just aren't moving fast enough from laptop to production? You're staring at data in your Lakehouse, notebooks are everywhere, and you're still coordinating models on spreadsheets. What if there's a way to finally connect all those dots inside Microsoft Fabric? Stay with me. Today, we'll walk through how Fabric's data science workspace hands you a systems-level ML toolkit, real-time Lakehouse access, streamlined Python notebooks, and full-blown model tracking, all in one pane. Ready to see where the friction drops out? From data swamp to Lakehouse, taming input chaos. If you've ever tried to start a machine learning project and felt like you were just chasing down files, you're definitely not alone. This is the part nobody romanticizes, hunting through cloud shares, email chains, and legacy SQL databases just to scrape enough rows together for a pass at training. The reality is, before you ever get to modeling, most of your time goes to what can only be described as custodial work. And yet, it's the single biggest reason most teams never even make it out of the gate. Let's not sugarcoat it. Data is almost never where you want it. You end up stuck in the most tedious scavenger hunt you never signed up for, just to load up raw features, exporting CSVs from one tool, connecting to different APIs in another, and then piecing everything together in Power BI, or if you're lucky, getting half the spreadsheet over email after some colleague remembered to hit send. By the time you think you're ready for modeling, you've got the version nobody trusts and half a dozen lingering questions about what exactly that column updated date really means. It's supposed to be smoother with modern cloud platforms, right? But even after your data's in the cloud, it somehow ends up scattered. Files sit in Data Lake Gen 2, queries in Synapse, reports in Excel Online, and you're toggling permissions on each, trying to keep track of where the truth lives. Every step creates a risk that something leaks out, gets accidentally overwritten, or just goes stale. Anyone who's lost a few days to tracking down which environment is the real one knows there's a point where the tools themselves get in the way just as much as the bureaucracy. That's not even the worst of it. The real showstopper is when it's time to build actual features and you realize you don't have access to the columns you need. Maybe the support requests data is owned by a different team, or finance isn't comfortable sharing transaction details except as redacted monthly summaries. So now you're juggling permissions and audit logs, one more layer of friction before you can even test an idea. It's a problem that compounds fast. Each workaround, each exported copy becomes a liability. That's usually when someone jokes about building a house with bricks delivered to 5 different cities. And at this point, it barely sounds like a joke. Microsoft Fabric's Lakehouse shakes that expectation up. Ignore the buzzword bingo for a minute. Lakehouse is less about catching up with trends and more about infrastructure actually working for you. Instead of 12 different data puddles, you've got one spot. Raw data lives alongside cleaned, curated tables with structure and governance built in as part of the setup. For once, you don't need a data engineer just to find your starting point. Even business analysts, not just your dev team with the right keys, are able to preview, analyze, and combine live data all through the same central workspace. Picture this. A business analyst wants to compare live sales, recent support interactions, and inventory. They go into the Lakehouse workspace in Fabric, pull the current transactions over, blend in recent tickets, all while skipping the usual back and forth with IT. There are no frantic requests to unblock a folder or approve that last-minute API call. The analyst gets the view they need on demand, and nothing has to be passed around through shadow copies or side channels. The security story is bigger than it looks too. Instead of gluing together role-based access from 5 different systems, or worse, trusting everyone just to delete their old copies, permissions sit right at the data workspace level. If you need only sales, you get just sales. If someone on a different team needs to reference inventory, they see what's necessary and nothing else. There's no need for late-night audits or accidental oversharing sent out in another email blast. This kind of granular control has teeth, and it means the system is finally working for you, not just IT compliance officers. Most ML tools promise easy access, but Fabric's Lakehouse sets it up for both sides. Technical users dive straight into raw data, analysts use the same space with understandable curated views. It eliminates most of those arguments about missing context, and it's the first time both sides can operate in parallel without running into each other. Suddenly, feeding a model isn't a 6-step puzzle. It's just picking from well-organized inputs. Now, don't get me wrong. Centralizing your data feels like arriving at the party, but you're still far from launching an ML model. Taming your input chaos only lines up the dominoes. You know exactly who has access. You've finally got a data system everyone can agree on, and everything's ready to pipe into your next experiment. But here's the sticking point. Even with this head start, most teams hit friction when it's time to move from wrangled data to actual feature engineering and model building. Notebooks are supposed to be the on-ramp, but more often they become their own maze of version conflicts, broken environments, and lost progress. So with your inputs sorted, both secure and actually usable, you'd expect things to speed up. But what's supposed to be the easy part, collaborating in notebooks, still brings plenty of pain. Why do so many projects stall when all you're trying to do is turn clean data into something the model can use? Python notebooks without the pane, streamlining the ML process. If you've spent any time actually trying to move a project forward in Python notebooks, you already know how this goes. It starts with a good intention. Let's reuse what already works. Just clone your teammate's notebook and hit run. But then you land in dependency purgatory. Pandas throws a version error. Matplotlib won't plot the way you expect. And half the code relies on a package nobody mentioned in the docs. Even inside cloud platforms that promise smooth collaboration, you're jumping between kernels, patching environments, and quietly dreading that awkward chat asking who set up the original development space. Instead of a sprint, it feels like you're wading through molasses. The joke in most data science teams is that there are always more notebook versions than people in the workspace, and nobody's sure which notebook even worked last. We've all seen that folder called Final Notebook, V5 Actual, IPNB and its 6 unofficial cousins. When everyone works in their own little bubble, changes pile up fast. Maybe your colleague added a new feature engineering trick, but saved it locally. Someone else tweaked the pipeline for the customer churn dataset, but didn't sync it back to the team folder. And you, working late, discover that the only working notebook relies on libraries last updated in 2021. Just setting things up burns through the first chunk of your project budget. Version control gets messy, dependencies drift, and suddenly the project's output becomes as unpredictable as the tools themselves. Now, let's be honest, this isn't just a confidence issue for junior data scientists. Even seasoned teams trip over this problem. Maybe you run notebooks through Databricks, or you're using Jupyter Hub spun up on a managed VM, but environments mutate, and tracking which projects have which libraries is a problem nobody admits to enjoying. Meetings start with 5 minutes of, wait, are you using the new version or the one I sent on Teams? It's a shared kitchen where every chef brings their own knives, and you're left with a half-baked stew because half the utensils are missing or nobody remembered whose batch was actually edible. This is one of the places where Microsoft Fabric flips the usual story. Each new notebook session comes pre-configured with the baseline set most people need: scikit-learn, pandas, PyTorch, and the rest. You don't have to run endless install scripts, fudge dependency versions, or file tickets just to get the essentials. The environment sits on a foundation that's stable, predictable, and updated by the platform. It means more time fiddling with your model and less time scanning Stack Overflow for fixes to some cryptic pip exception. But availability isn't just about libraries. It's about getting right to the data, right now, not after a 12-step API dance. Fabric's notebooks tie directly into the Lakehouse. No jumping through hoops, no awkward connection strings. You click into a workspace, the Lakehouse tables are ready for you, and you can immediately experiment, sample data, engineer features, and build holdout sets without copying files around the org. You're not hunting for which cluster has access or figuring out what secrets JSON someone left behind. The workflow moves the way you expect: explore, code, iterate. Let's say you're a data scientist actually kicking off a new experiment. You spin up a new notebook inside your team's Fabric workspace. You need last quarter's sales, customer feedback scores, and inventory turns. All of that is sitting right there in the Lakehouse, live and ready. You pull in your sales data, engineer some features, maybe encode product categories and join the support tickets, then train a quick baseline model. It's familiar, but minus the usual overhead. Nobody comes knocking about missing files. There's no scramble to reconfigure your environment, and you're not storing scripts in 5 different clouds just for peace of mind. The bigger payoff comes when you want to share progress with your team, or more critically, not lose progress in the shuffle. Fabric's notebook environments are mapped to version-controlled workspaces. Every time you make a change and hit save, the history stays attached to your session. You don't end up with that email chain labeled for review, followed by 3 different latest versions shared through Teams. Your experiments, failed runs, tweaks to hyperparameters, and new feature sets all live in the same trail, and they're accessible to your colleagues. There's no walled garden for who did what. Collaboration is built in without tacking on yet another Git repo or hoping folks actually use the right naming convention. All this means there's far less friction between idea and execution. Instead of spending days in setup hell or losing work to version confusion, teams using Fabric move fluidly from the raw data in the Lakehouse to a working model. The usual blockers, missing libraries, mismatched environments, progress lost in translation, just don't show up as often. Sure, real modeling still takes thought and tuning, but at least the tools aren't stacking the odds against you. Of course, as soon as you start getting solid results in these notebooks, a new problem appears. Keeping track of what actually works, which model gives you the right lift, and who changed what settings becomes its own maze. When the team gets to production, it's all too easy for chaos to creep back in. The good news with integrated model tracking and governance up next, Fabric finally gives organizations a way to lock down the output, not just the inputs and code. And this is where the wheels usually come off in other platforms. Model tracking and governance, keeping the output under control. If you've spent much time actually getting models into production, you already know that training is only half the story. There's a certain point where every data team runs into something far less glamorous, tracking what got trained, with which data on which day, and figuring out which model is running where. For most teams, this part isn't just annoying, it's the step that gets skipped until it turns into a fire drill. The reality? Model management in the wild looks like a tangled mess of folders, final v2, donut delete, the infamous backup old, and a spreadsheet that's never quite in sync. There's usually someone on the team who tries to keep a wiki or OneNote page with dates and file links, but that plan falls apart as soon as one person heads out on vacation or switches projects. When something breaks, all bets are off. Production predictions start looking strange. An executive asks why customer churn jumped for one region, and the investigation begins. If you can't easily answer questions like what code generated this result, or which training data did you use last quarter, you're headed for some long hours. It's like someone's dumped a jigsaw puzzle onto your desk, but hidden half the pieces in other departments' team sites. In regulated industries, the stakes jump even higher. You'll be asked for explainability, lineage, and concrete proof that every model's been reviewed and approved by the right people. Most data science tools leave you building that audit trail by hand or exporting piles of logs that no one actually checks until something's already gone wrong. Take, for example, an ML audit. You're sitting in a meeting with compliance and they want to know step by step how your model predicted that a customer would likely cancel their subscription next month. There's no handy undo for this sort of thing. If you're relying on old screenshots, emails, or hope, it feels less like data science and more like forensic accounting. Explaining why one cohort got flagged and not another becomes a guessing game. Cohorts and weights might have changed between version 1.3 and 1.7, but without clear records, the question of why becomes a black box. That's the kind of pain point that Microsoft Fabric addresses head-on. By folding in MLflow under the hood, Fabric changes what's considered table stakes for model management. Every time you train a model, Fabric's MLflow integration records not just the code, but the dataset version, environment details, hyperparameters, metrics, and even output artifacts. These aren't just blobs of metadata. They're searchable, browsable, and attached to real experiment runs. Gone is the guesswork. The platform keeps exact records, so you don't have to maintain a parallel system of spreadsheets and file shares just to track what's changing. Imagine you're on the business side and need to answer a question about customer churn. Instead of putting in a support ticket or pinging 3 analysts, you open the Fabric interface, look up the churn model, and see a timeline, every training run and deployment with who did what and even which data set powered which experiment. It's not just a snapshot in time. You get the full journey, training data, code version, manual notes, performance metrics, deployment approvals, all bundled and tagged in one timeline. This makes proposals and approvals much less of a bottleneck. If the compliance lead or head of a business unit needs to approve a model for release, they're not searching through emails or exporting audit logs. Approval workflows are built in. Who signed off, when it was signed, and what was reviewed is baked into the record along with role-based access. Only the right people can make changes or greenlight deployments, but everyone who needs traceability has it out of the box. Even as models evolve, you retain a clear lineage. If a new version goes live and the KPIs shift, you can look back and see what changed, who changed it, and even download the old code and data for reruns or explainability. It's almost a surprise how much smoother everything runs when tracking and governance are built into the same platform as the notebooks and data. You want to try a new approach or roll back to a previous model version. It's 2 clicks, not a 6-user chase across 3 SharePoint sites. Regulatory events don't send panic through the team because that audit trail was created automatically, not as a painful afterthought. The business can have confidence that every model in play is accounted for and can be explained. But now that traceability and governance are finally reliable, there's a pivotal question left. Can you actually deploy your model without blowing up the project's timeline or budget? Managing the model lifecycle is one thing. Moving from lab experiment to live production value is where most systems crumble. Whether rollout happens in 2 days or 2 months, it always comes back to making deployment and scaling less of a minefield. That's where Fabric's approach to model serving and operations changes the game. You're no longer left guessing how much production will cost or whether your model will even get used outside of a demo. Deploying and scaling ML from prototype to business value. If you've made it as far as training a model in your Fabric environment, you're ahead of most folks. But the finish line, actually getting that model to power a business process or app, is where the real friction sets in. You'd think that with all the automation in modern ML platforms, getting a model from works in my notebook to running in production would feel automatic. The truth is, this is still the phase that slows teams down. Most organizations follow a handoff ritual that feels archaic. You finish your code, and then you lob it over the fence to another team. They review your scripts, refactor half of it for their stack, maybe rewrite it entirely, and then spend weeks arguing about deployment targets and resource sizing. During all that, the approved model might keep changing upstream, so what goes live isn't even the version you meant to roll out. Not exactly empowering when you're being asked to account for business impact on a quarterly review. You'd be forgiven for thinking the hard part should end with the model passing its accuracy checks. But even after code hits production, there's the question of scale and the unwelcome reality that costs can spiral fast. It isn't just the compute for running your model, it's the monitoring, logging, retraining cycles, and the sprawl of endpoints barnacled onto your cloud bill. A lot of orgs drift into a pattern where models go live, sit untouched, and quietly decay. No one's watching performance, feedback loops break, and data drift creeps in. Suddenly you're fielding questions about why numbers look so off, only to discover the model running in production is not anywhere close to the latest, or worse, it costs more just to keep the thing warm than your entire training budget last month. This isn't just a finance headache, it's a credibility risk for the whole data team. Let's make this real. Say you launch a new app feature powered by a shiny fresh model. You celebrate the release, everyone nods, and within a few weeks, the finance lead is quietly frowning at the cloud bill. Usage spikes, costs balloon, and now you have to answer for why the automation is eating your margins. Meanwhile, someone in a different team realizes no one's monitoring live predictions anyway, so performance is anyone's guess. It's like running a fancy new coffee shop where you spend more on espresso machines than the revenue from customers, and nobody's quite sure who's checking the inventory. This is the part of the ML lifecycle that Microsoft Fabric tries to simplify without forcing you into more trade-offs. Instead of treating deployment as a separate ops problem, Fabric turns it into a self-service menu. Models get deployed as managed endpoints or batch jobs right from the workspace where you build them. That means you pick how you want your predictions served, as a persistent web service ready to handle incoming requests, or as a scheduled offline job that runs overnight and populates results wherever you need them. You choose the cost profile, you set the scale. If you only need to run forecasts once a week, you don't pay for a server to sit idle all month. If your use case gets busier, scaling is done via settings, not a new infrastructure project. Monitoring is bundled in by default rather than stringing together third-party plugins or writing custom scripts to keep watch on your endpoints. Fabric gives you hooks to view requests, check usage stats, and flag issues right where you manage the model. If retraining needs to happen based on new data or drift, you wire it up with automation, no awkward manual interventions. Your ML pipeline isn't frozen at launch. It stays live, adaptable, and refreshable. A lot of teams find this especially useful for business apps built on Power Platform. Let's say your sales and ops team wants live forecasts in their dashboard. with numbers powered by your Python model. Fabric lets you expose your ML predictions as web services, which Power Apps and Power Automate can consume directly. Each request is tracked, and every round trip between app and model is logged, so you see exactly what's being used, when, and by whom. You're not playing catch up with finance every month. Cost transparency is part of the everyday reporting. If something isn't providing value, you catch it early instead of getting blindsided after a quarter. And for anyone who's tried to make a model stick in production, the automation here is the hinge point. Schedule retraining based on actual usage or model performance, or even redeploy on a rolling window as new data becomes available. You set it up, Fabric takes care of the mechanics, and the whole thing is documented alongside your other governance controls. If the business wants a snapshot of how things are running or needs to prove compliance, you've got a one-click export, not a frantic night stapling logs together. When you look at it from end to end, Fabric's focus on deployment and scaling means your machine learning lifecycle actually completes the loop. Models aren't just pilot projects or analytics eye candy. They drive business value at a cost you can predict, backed by real transparency. You spend less time patching together operational hacks and more time finding new ways to put your ML models to work. Now, with data feeding your models, experiments tracked, and production under control, there's a bigger shift happening under the hood. Fabric's ecosystem means AI stops being someone else's problem down the hall and becomes a shared platform. Suddenly, your next project can move faster, and your impact as a data scientist or business user stretches a whole lot further. The next step is thinking about how this system-level approach shapes not only one project, but your overall approach to machine learning in the enterprise. If you've ever felt like your ML workflow is more duct tape than design, you're seeing the problem Fabric tries to fix. The platform doesn't just polish up the model itself, it smooths out every rough edge, starting with the way data lands in Lakehouse through to notebooks and finally deployment and monitoring. It forces the parts to fit together, making those pilot projects feel less like experiments that never launch. If this is where your data science work has stalled, it's worth reconsidering your process. Want more walkthroughs and concrete results? Hit subscribe and start taking your models further.